This is lab 3, black hole orbit. So the problem of this lab was that we were given the mass of the star, the g constant, and the position of the star as it orbits a black hole. So the whole point was to find the mass of the hole by using the model through Python to find the magnitude of Fnet and plug it into the formula F equals g times m1 times m2 over r squared. So overall, we found the mass of a black hole, which was 2.61 times 10 to the 31 kilograms. In this lab, the momentum principle is very important, as we find that Fnet is equal to dp over dt. Now, p is equal to mv. And as we find dp, which is a change of momentum, we also are the star mass is given, and we use dt as a change of time, which is 86,400 seconds. Now we find that Fnet goes into two components of dp dt, which are parallel and perpendicular. Now some code used for the momentum principle is that we have all these initial and final values. Now what we do with these initial and final values is we find the change between them to get the delta p and the delta v. Now, it all goes back to this formula of Fnet equals dB dt parallel plus dB dt perpendicular. Now, the important thing is we find the dB dt parallel, which is dmag p dt times p hat. And as you can see, p hat is the unit vector of momentum, and we see that dmag p dt is magnitude of the momentum final minus magnitude of the momentum initial divided by delta t. Now as we multiply those together, we get dp dt parallel. Now we can use the Fnet equation to find dp dt perpendicular, which is equal to Fnet minus Fnet parallel. Now, as we're on this quest to search for the mass of the black hole, we have to use Newton's law of universal gravitation, which is F equals g constant times m1 times m2 over r squared. So Fnet is found through the momentum principle as shown earlier, and the star mass is given, so we just have to find the other mass, which is the black hole. So the position is given to find r squared, and we just use code to find out the black hole mass. So we just do black hole mass is equal to magnitude of Fnet times the magnitude of r squared over g times star m. This is just basic algebra, and it comes out to be, as we said earlier, 2.61 times 10 to the 31 kilograms. Now this is a little screenshot that I took from my code being run, and we have 3 arrows. So arrow 1 is the yellow arrow, and it is Fnet. It is showing Fnet. Arrow 2 is the blue arrow, and it shows Fnet perpendicular. And arrow 3 is the black arrow, and it shows Fnet parallel. And as you can see, that is definitely Fnet parallel. What does it mean? So in this lab, we were asked, what does it mean by the difference? What is the difference between dp dt parallel, dp dt perpendicular, and Fnet parallel and Fnet perpendicular? Well, we got to start from the beginning. So Fnet is equal to delta p over delta t, as delta p and over delta t equals dp dt parallel plus dp dt perpendicular, and Fnet goes into Fnet parallel plus Fnet perpendicular. We can use these and make them equal to each other to where the components are equal to each other. So dp dt parallel is equal to Fnet parallel, and dp dt perpendicular is equal to Fnet perpendicular. So another what if question is questioned in this lab. So it says, imagine the black hole whose mass you found was removed and a different black hole was placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the black hole. Could you tell the difference? So what it's basically asking is, if we have everything the same, the g constant is the same, the mass of the star is the same, and the position is the same, so could we, and Fnet is the same, could we find the could we find a different mass for the black hole? And that's not possible because F net has to be different. So because everything else is the same, F net should be different, and therefore because it's not, we cannot find the mass of the new black hole. In conclusion, in this lab we used the momentum principle of F net equals dp/dt parallel plus dp/dt perpendicular and Newton's law of universal gravitation to find the mass of the black hole, which was 2.61 times 10 to the 31 kilograms.